Start recording. Two conversion factors. Tell your partner or someone near you what those two conversion factors are. Grab a little slip, name, date, why you were late. There's a little slip on the chair just outside. Yes. I'm going to come closer so I can hear you. Yes. So you're using the first. This is an ion. Okay. Nobody? Yes. We know our particle ratio. Yeah, just right there. Great. Thank you. Particle ratio is number 1. Number 2, grab a little slip of paper from the chair, write your name, your date, and why you were late. Okay? And number 2, avocado. Not avocado, but Avogadro. Avogadro's number. Okay, so what is the particle ratio? We can't give a particle ratio without an example. Okay, so we would have to say, for example, if we had C2H6, the particle ratio could be 2 C atoms per 1 C2H6. Or it could be 2 C atoms per 6 H atoms. Or it could be 6 H atoms per 1 C2H6. So all of those are particle ratios. How do you find a particle ratio? You have to write the correct formula. Write the correct formula and then count. Okay? Avogadro's number. That's the one where we have a mole. 1 mole of particles is equal to, what's the number? 6.02 times 10 to the 23rd. And if you have trouble remembering the power of 10, it's as easy to remember as, well, I need my highlighter. 1, 2, 3. Oh, look at that. Yeah? So if you have trouble remembering, if you can get the 6.02, then it's as easy as 1, 2, 3 to remember the power of 10. So those are the two conversion factors we know so far. And on page 20, oh, I got to go way back. Here we go. Here we go. We have some 2-step mole problems. So we're going to be using both conversion factors, Avogadro's number and the particle ratio. And we are going to say, if we at this point have moles of molecules, we can convert from moles of molecules into the number of molecules And in order to do that, we will use 6.02 times 10 to the 23 molecules equals 1 mole of molecules. I found the calculator, Dylan, on that desk right there. Okay, so you're off the hook. Once you know the molecules, you can say, well, how many atoms or ions or whatever are in that thing? And from there, you can use the particle ratio. This right here is the particle ratio to convert between molecules and atoms. Okay? So you can go from moles of molecules to molecules, and from molecules you can go to atoms. Or if I gave you a number of atoms, you could find how many molecules you could make, and you could find out how many moles of molecules that would be. Okay? So let's try the first one together. All right? How many O atoms are in? So I'm going to start my little thing here. I'm going to say, how many O atoms?
Please excuse this interruption. If we could please have the grade 8 students who need immunizations to head to the library, please. Again, grade 8 students, please head to the library. Thank you.
So start your mathematical sentence with saying, what am I solving for? I'm solving for O atoms. What am I starting with? I'm starting with the number 3, and the 3 attaches to the unit moles. So we're starting with 3 moles. And we never just write moles. We're always going to write moles of something. Okay? What do we have moles of? Sodium phosphate. And let's remind ourselves, sodium is +1. Phosphate is PO4 3-, so the formula for that is Na3PO4. So we have 3.0 moles of Na3. Whoops, why am I writing the 3 up top? 3PO4. Then I look at my little mappy thing up here and I say, I can go from moles to molecules, or in this case, it's formula units, but you can just call them all molecules if you want to, like just to make it easier. You can be like, sure, it's a molecule, whatever, close enough. All right. In other words, we're going to be finding the number of Na3PO4s. Okay. So we're going from the moles of Na3PO4, we're going to find the number of Na3PO4, because we can convert between moles of A and the number of A. Then we're going to convert from the number of A to the number of particle B. Okay, and for that we use the particle ratio. Okay, so now we're going from molecules. In this case, we're going to O atoms. Okay, so that's our O atoms that we're going to finish with. So we need to start by canceling out moles of Na3PO4. You see how it's up here? Moles of Na3PO4. So we're going to write that down on the bottom. Moles of Na3PO4. And then on the top, we're going to write, well, we're going from moles to molecules. So we want to find the number of Na3PO4. I'm going to call them formula units, but if you call them molecules, that would also be okay. Yes, I'm okay with that. That cancels out moles, and that leaves us with the number of Na3PO4. Now we say to ourselves, what numbers go here? And that's where you need to know Avogadro's number, which is 6.02 times 10 to the 23. Okay? Now, 6.02 times 10 to the 23 goes with molecules. The 1 goes with the mole. And do you remember how the 1 went with the prefix? The 1 goes with the prefix. 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 Well, we have a new one. The 1 goes with the mole. The 1 goes with the mole. It's not nearly as catchy because it doesn't scan properly, but you already know the song, so let's all sing it together. The 1 goes with the mole. The 1 goes with the mole. If I don't hear you, we're standing up and going around the room in a circle. So let's hear everybody. And the hand actions too, please. The 1 goes with the mole. 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 Does that make sense? I guess it doesn't make sense. That's just a song. Think about it though. What if I were to say 1 donut is equal to 12 dozen donuts? Would that make sense? Does that sound sensible? 1 donut is 12 dozen donuts. Those are the same. Is that true? No. That would be like saying 1 atom is equal to 6.02 times 10 to the 23 moles of atoms. That's the same illogical, incorrect statement. Both of those are wrong. Okay? Because mole means 6.02 times 10 to the 23. Yeah? So you can't have a mole of moles. That's silly. Yes? And if that did not make sense to you, if you're like, I don't understand that, that's okay. You can just remember that the 1 goes with the mole. The 1 goes with the mole. And so you need to put the 6.02 times 10 to the 23 with the thing that is not the mole. Yes? Okay, so let's look here. Where is the mole? On the top or the bottom? Where is it? It's on the bottom. So what do we put with the mole? 1. And what's the number? 6.02 times 10 to the 23. Okay, so we have made it here now. We've made it to Na3PO4. Would you be able to convert Na3PO4 into O atoms? Do you know the conversion factor between Na3PO4 and O atoms? How many O atoms? Show me your fingers. How many O atoms in Na3PO4? Okay, we all got 4. There are 4 O atoms in every 1 Na3PO4. So the Na3PO4 cancels out, and we are left with O atoms. So we've done a 2-step conversion there. And we get, I don't know what we get. I need a calculator. We've got 6.02 E23 times 3 times 4 equals 7.224 times 10 to the 24. Unless I did my calculation wrong. 3 times 6.02 E23 times 4 is, yep, that's correct. Now, what's our unit there? O atoms. Excellent. O atoms. Yay. And what else should we be thinking about? Sig figs. Okay. How many sig figs in 3.00? Everybody, how many sig figs in 3.00? Show me your fingers. 3 sig figs, yay. Okay, how many in 6.02 times 10 to the 23? 3 sig figs. How many in 4 atoms? Infinite. Because it is a counting number, yes? There's not approximately 4 O's in Na3PO4. There's exactly 4 O's. So that is an exact number. See why we don't need a midterm in this course? Because we go back and we're like, oh, here's stuff from Unit 1, right? Here's stuff from Unit 2. Write the formula, that's Unit 4. Okay, exact number, therefore infinite sig figs. Same thing with this one down here. That 1 is also infinite. So we need to have 3 sig figs in our answer. So that's going to then round to 7.22 times 10 to the 24 O atoms. Put a box around it to show that you are done. Is good? Okay. Shall we try one more? Let's try one more. And look, we've even got this up here for you at the top. So you can say, am I starting with moles or am I starting with atoms or ions? Where am I starting and where am I ending? How many chlorate ions? That's what I want to get to at the end. Yeah, I want to end with chlorate ions. Chlorate is ClO3 minus ions. So we are starting with ions. That means we are starting over on the left. We are going to convert that into molecules or formula units. What are we looking for the molecules or formula units of? What is the compound? Magnesium chlorate. What's the formula for magnesium chlorate? Mg ClO3 bracket 2. Excellent. Okay, so we're going to go working backwards. This is our end point. That's where we want to finish. Working backwards, we're going to be having MgClO3 MgClO3 and then working backwards, what did we start with? Actually, I probably should have started with what we started with. That would have made more sense, but I did not. Silly me. We are starting with 0.42 moles of magnesium chlorate. So we have 0.042 moles of MgClO3 So now we have a map of our problem. We know that we have 2 steps, and we know we are starting with moles. This is our start. Nah, that was supposed to be highlighting. That made me sad. Start. End. So, how many chlorate ions? And we are starting with 0.0042 moles of MgClO3 That's our starting point. We have 2 steps, so I'm going to have times line, and I haven't really left myself enough room, so I'm going to have down here times line, okay? we will be canceling this unit here. So this unit here needs to go on the bottom. Moles of MgClO3 2. And in step 1, we are converting into the number of MgClO3 2. You can call them molecules or you can call them formula units, okay? Right? If you look in your path, we started with moles. Now we're moving to molecules, okay? And then after molecules, our formula units, we're going to want to cancel the MgClO3 2 formula units, and we want to find ClO3 minus ions. How do we go from moles to particles? What's the ratio between moles and particles? That would be Avogadro's number. So, how do we go between formula units and moles? We use Avogadro's number. Does Avogadro's number 6.02 times 10 to the 23, does it go on the top or the bottom here? It goes on the top, 6.02 times 10 to the 23 formula units, because remember the 1 goes with the mole. Then we want to convert from one type of particle, the formula unit, to a different type of particle, the chlorate ion. And this is where we use our particle ratio. And we just look at the formula and we say in every 1 MgClO3 we have 2 chlorate ions. And then you chuck this all into your calculator, 0.0042 times 6.02 E23 times 2 equals 5.0568 times 10 to the 21. Do we love that answer? Yes. Uh-oh. Is it 0.042? Oh, I'm so sorry. Thank you, thank you. Let's get rid of that 0 there. Just 0.042. And that will mean that this is times 10 to the 20. Thank you, thank you. Oh, it's 22, because my brain is just a little bit backwards. All right, 22, thank you. Good thing I've got you guys. Keep me straight. All right. How do we like my answer? Yeah. Even without that, like, power of 10 error, it's still not very good. What's wrong with it? Sig figs. So let's see, we have 2 sig figs, and we have 3 sig figs. And how many sig figs in 1 mole? Infinite sig figs. Whenever you have 1 mole, it's always infinite. How about this 2? Infinite. And this 1? Infinite, because those are exact, they are counting numbers. Okay? So we have 2 sig figs and 3 sig figs, so that gives us 2 sig figs. That will then round to 5.1 times 10 to the 22. And now I'm done. Oh, I need some units. Yes, I need some units. Well, I've canceled out moles of MgClO3. I've canceled out the number of MgClO3s, and all I am left with is ClO3 minus ions. And then stick a box around it. Do you guys want to try 3, 4, 5, 6, 7, 8? 9, 10? Try a few of them, see how they go, and then we're going to learn something new. Okay? So this is pages 21 to 23. If you don't actually cross them, that's okay. As long as you have the units. Okay?
I was just like,
Okay. You go. Oh, it doesn't have 7, 8, 9, 10. Okay, okay, yeah. Oh, okay. But yeah. Let me write these down. Yes. So you have 2A. And it's just yeah. The flash is gone. Splashed out of existence. Hi. How would you show it? Yeah, okay. So you would say I got this times that and then times. And then you would say I have 2 CLO. And that's good. So you go, point oh four two. Yeah. Times 2. Yeah. So, okay. And then times. Good.
So this part of this one.
Yep, and if you have something on the bottom, you just divide by it instead of that. Yep. Let's say this number was on the bottom, we would say 0.042 divided by times. Yeah, yeah. Exactly. Let's try some. Very nice.
Yes. Yes, I can. I hear you. Yes, yes. Yeah, so this is not small, this is walls, so you can write walls and C's. You could write walls. Yeah. You're just subbing. Yeah. Okay, so these are processed. Not just that. Yeah. 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 Yes. Yeah. Yeah. Yeah.
I'll be right there. I'm just checking my math on something. It's 5. Do your math again.
Okay. So we have, we'll find that, we are starting with 5. So we need to write the formula for iron and so that is the charge of iron. You either start here or you're getting or you start at the stuff. Oh my boy. If you're buying molds, you're going out. Yes. Yeah. Yeah, for sure. Okay, so I think we just that's over funds. Okay. Now you need that pop down to a little neutral charge. So, we're balanced. Now, you have a 3 plus, 2 minus. Yes. So how have we even makes sense. How many 3 plus do we need makes sense? 3 plus 2 is 9 plus. 2, right, having 2. Right, yeah. I'll write down this. Okay. Okay. And then read down the one. Yep. And then I support. 3? Yes. Down the bottom. Yeah. And then yes. And then. 5. And we have some for it. Hello. I don't understand. Yeah. Yes, they are. We covered this. Oh, I thought we were adding. Oh. Thanks. You're such a smart guy. Just like yeah. I can't be. That's yes. We're going to do the next stress. All right, anyone need a hand over here? Good for now? Okay. I didn't. Okay, so now you're going to write down 5, and then I got 5. That gives you as a formation. Okay? And then the all That would be. Yeah. And then. Yeah. Yeah. Okay, nice. Okay. Okay. Yeah. Yeah. It's not good there. See them every day, like. You good? Yes, it's good. Yes. Well, it doesn't matter. You need to show me. That's what it's here. Okay. Yes. You're gonna say. Yeah. I use that every time.
That's why.
Yeah.
Yeah.
Yeah. Oh, I'm so sorry. You were talking about the price. Yeah. Yeah. We do. Yeah. Yes.
Yeah.
And you will have this announcement.
Oh, that's what. Oh, God. Bro. Oh, it is.
How we doing? Okay, good. Yes, it is.
That.
That. All right, good. Yeah.
This is good. Looks good.
Yes. This is always just gonna be the number, and not the same big small number, and small. I'm saying. And how many of those? So one thing we can first. So this one. So why do you want to take? Okay, so let's start by doing service. Have, or, oh, wow. So balance. Balance to follow those that feel like the way to go. So right, you're using the facts. Sorry. Okay, now. Yeah. All right. Thank you. Yeah. Yeah. You don't. It would be bad. Okay. Yes. So, that.
Please interruption. This is the last call for any students who have not yet received your immunization, so please go to the library now. Again, last call for any students who have not yet received your immunization, please go to the library now. Thank you.
you want, okay, I'm gonna, I think. Yeah, yeah. Thank you. So, three, divide by. Divide by 6. And that is. Oh. So that's confused. Then you can say. So that's perfect. And what number? Yeah. It's not important, aesthetics are important. Okay, and want to jump on.
All right, friends, we're going to do something a little bit different for a few minutes. We are going to go to 5.1i. 5.1i, which is on page 24. All right, so we are on page 24. 24. The mole ratio is just a particle ratio's big brother, right? And the particle ratio, if you recall, let's say we had this N2O4 molecule, yes? We have 2 N atoms for every 1 N2O4 molecule. So far, so good. We all know how to do that. Are we paying attention, or are we off in la la land? If we're off in la la land, let's not be in la la land. Let's come back here. Now, if we have a pair, how many is a pair? A pair is 2. So if we have a pair of N2O4 molecules, there's a pair, there's 2 of them. We have 2 pairs. There's 1 pair, there's 2 pairs of nitrogen atoms. The ratio is still 2 pairs of N atoms to 1 pair of N2O4. We still have the ratio 2 to 1. 2 to 1. So far, so good? Okay, we're just scaling that ratio up. Now, if I give you a dozen N2O4s, okay, so we have 1 dozen N2O4s, that's 12 of them all together. Let's count how many dozen N's we have. If I count across here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 N atoms. That is 1 dozen N atoms across that top row. So this is 1 dozen N atoms. Yeah? And if I add the next row, that gives me 2 times 12 is 24. That's 2 dozen N atoms. Yeah? 2 dozen. So if I have 1 dozen N2O4, that means I have 2 dozen N atoms. And the ratio is still 2 to 1. So I can have 2 atoms to 1 molecule. I can have 1 pair of atoms to 1 pair, 2 pairs of atoms to 1 pair of molecules. I can have 2 dozen atoms to 1 dozen molecules. And if we scale it up even further, we can have 2 moles of N atoms for every 1 mole of N2O4 molecules. The ratio is still the same. So let's try, we can do another example here. If you have a 2 to 4, there's 2 N atoms for 4 O atoms. If we did that in pairs, it would be 2 pairs of N atoms for every 4 pairs of O atoms. Yeah? 2 pairs N for 4 pairs O. If we did dozens, that's 2 dozen N for every 4 dozen O. And that means for moles, it's going to be exactly the same. There's going to be 2 moles of N for every 4 moles of O. Okay? So if we have to write this ratio, for C2Cl6. We want to write the mole ratio for C atoms to Cl atoms. So that would be moles of C atoms to moles of Cl atoms. What number would go on the top? Our formula is C2Cl6. 2. And what goes on the bottom? 6. So it's exactly the same as the particle ratio, but we stick the word mole on the top and on the bottom. And it allows us to do a shortcut. So if I have moles of C atoms, I can go directly to moles of Cl atoms without having to take 3 steps to do it. Okay? The mole ratio for moles of C atoms to moles of C2Cl6 molecules, what number goes on the top? 2, because there's 2 C atoms in every 1 C2Cl6 molecule. So, if you have finished pages 21, 22, and 23, you can start working on 26, 27, 28. All right? Have 11. Okay, so finish pages 21 to 23. I might do a homework check on this tomorrow. Wouldn't that be fun? Right? Yeah. I'll do a homework check on that tomorrow. All right, and if you want to work ahead, if you're bored right now, you can do 26, 27, 28. And that means if you're having trouble with it, you can drop by after school today, or you can drop by tomorrow flex, or tomorrow lunch. Yeah. So you need to finish 21 to 23 if you want to work ahead. You can Oh yeah, I am. I forgot about that. I did not bring that up clothes. So there we go. Then I don't need to do it, right? Okay, cool. Okay, cool. Hi. So basically 5.32D needs fixing. Okay. But there's a video for that part, right? Okay, cool. 5.2D needs fixing. 5.2D needs fixing. Yay. Hello. Hi. Yes.
Yeah. That looks really good. Very good.
Yeah, this is one unit where if you don't do the practice, you won't do well. Unless you're a genius, in which case you'll do well anyways. Hello. Yes.
This one.
Yeah, but do it like that. Yeah.
And another thing is I walked some, yeah,
Sure.
some of them walked.
That's okay.
That's it. All right.
Cool, cool. Just throw it in there. Yep, nice. Thank you, thank you. And for everything in there. Yeah, everything. Just go back.
Okay. Now let go.
Yep, that's right. Thank you, thank you.
And the lesson will be online.
The lesson will be online, and I'm doing a homework check tomorrow on number 1 because I want to make sure that people actually do the work.
Yeah.
Yeah.
Okay.
Hi. Thank you so much.